Do freshmen really have the heaviest backpacks? By Sabera Hussein and Ayesha Rahman.
Our question was, is there a difference in mean backpack weights between grade levels? We have always been curious about whether or not there was a difference between the backpack weights of different grades.
There are always so many freshmen running around school with huge backpacks, but then we see many seniors with barely anything in their bags. We wanted to see if there was truly a difference between various grade levels and their backpack weights.
Hypothesis. Our null hypothesis was that there would be no difference between the mean backpack weights between grades, and our alternative hypothesis was that there would be a difference between mean backpack weights between grades.
Freshmen may think that they need different binders for every class and have not yet learned how to reduce space or weight of their backpacks. However, as students advance in grade level, they may learn how to reduce this unnecessary weight as they reduce their number of binders and books and learn about their backpack capacity.
Data analysis. We will analyze our data by using an ANOVA test and 6 two-sample t-tests. The ANOVA test will help us reject or fail to reject our null hypothesis, and the two-sample t-test will help us find out exactly where the difference is.
For our data collection, we conducted a multi-stage sampling procedure. Multi-stage sampling divides large populations into stages to make the sampling process more practical. In this study, our large population was the students at East Meadow High School. A combination of stratified sampling or cluster sampling and simple random sampling is usually used.
For our observational study, we had 4 strata. Strata 1 was freshmen, Strata 2 were sophomores, Strata 3 was juniors, and Strata 4 were seniors. Using a multi-stage sampling technique, we took 6 classes from each grade and sampled 5 students from each class, giving us 30 responses from each strata. Each time we went into a classroom, we would ask the teacher for permission and then randomly choose 5 students to weigh their backpacks.
We chose the students with an even split between males and females and weighed their backpacks with a luggage scale. We then recorded each weight in a data collection table and calculated the mean weight for each grade. This is our data collection table. These are pictures. The one on the left is the luggage scale that we used, and the one on the right is one of us weighing the backpacks.
Box plots. All the box plots for each grade are somewhat symmetric, and there are 2 outliers for juniors and 2 outliers for seniors. The outliers for juniors are at 20, 24, and 26, and the outliers for seniors are at 20.5 and 23. The box plots for freshmen and sophomores are very similar in their spread, whereas juniors and seniors have a very big difference in their spread. Each grade's backpack weights median appear heavier than the one preceding them.
The median for freshmen is 15.1, sophomores 15.65, juniors 12.4, and seniors 7.8. It is clear that as the grade gets greater, such as freshmen to seniors, the median backpack weight gets smaller, and the IQR gets smaller as well.
We conducted an ANOVA test to see if there was a difference. So our null hypothesis was that there was no difference and that they were all equal to each other. However, our alternative hypothesis was that they did not equal each other. Our conditions were that there were 4 independent SRSs as stated within and between groups. We also did the 10% condition, where it was reasonable to assume that there are more than 300 students in each grade.
For normality, we use the CLT since each group has an n greater than or equal to 30, so we applied the central limit theorem and approximated a normal model for each distribution. We also had equal variance for each distribution according to the box plots. Since conditions have been met, we constructed an ANOVA test with 3 degrees of freedom.
We found that our p-value was significantly less than alpha, and we were able to reject HO. There was sufficient evidence to suggest that there is a difference between mean backpack weights between grade levels.
To see where the difference lay exactly, we conducted 6 two-sample t-tests. Test 1 was between the mean weight of grade 9 and grade 10, 2 was grade 9 and grade 11, 3 was grade 9 and grade 12, 4 grade 10 grade 11, 5 grade 10 grade 12, and 6 the mean weights of grade 11 and grade 12.
Our conditions for the two-sample t-test were 2 independent SRSs as stated. Our second condition was that it was reasonable to assume that there are more than 300 students in each grade. And our third condition was that since our sample size is greater than or equal to 30, we were able to apply CLT and approximate a normal model. Since our conditions were met, we were able to construct a two-sample t-test with 29 degrees of freedom.
The two-sample t-test formula is T equals x bar 1 minus x bar 2 minus the parameter over rad standard deviation squared of 1 over n1 plus standard deviation squared of 2 over n2.
Our first test was freshmen versus sophomores. Our null for this test was that the freshmen and the sophomores' mean were equal, and our alternative was that the freshmen had greater means than the sophomores. We had our t-statistic as 0.635 and a p-value of 0.2638. Since our p-value was greater than our alpha of 0.05, we failed to reject HO. There is sufficient evidence to suggest that there is no difference between mean backpack weights between freshmen and sophomores.
For our second one, we did freshmen versus juniors with a null hypothesis of mu9 equals mu11, and alternative of mu9 is greater than mu11. We had a p-value of 0.01 and an alpha of 0.05. Because our p-value was less than alpha, we rejected HO. There was insufficient evidence to suggest that there is no difference between mean backpack weights between freshmen and juniors.
Our third test was freshmen versus seniors. Our null hypothesis was that the mean of freshmen was equal to the mean of seniors, and our alternative was that the mean of freshmen was greater than the mean of seniors. We had a t-statistic of 5.060, and we had a p-value of 3.62 times 10 to the negative 7. Since our p-value is less than alpha, we reject HO. There was insufficient evidence to suggest that there is no difference in mean backpack weights between freshmen and seniors.
For our fourth test, we did sophomores versus juniors. Null hypothesis was mu sophomores equals mu juniors, and alternative was mu sophomores is greater than mu juniors. We had a t-value of 1.715 and a p-value of 0.046. Since our p-value is less than alpha of 0.05, we rejected HO. There is insufficient evidence to suggest that there is no difference in mean backpack weight between sophomores and juniors.
Our fifth test was sophomores versus seniors. Our null hypothesis was that the mean of sophomores equaled the mean of seniors, and our alternative was that the mean backpack weights of sophomores was greater than the mean backpack weights of seniors. We got a t-value of 4.98 and a p-value of 3.29 times 10 to the negative 6. Since our p-value is less than our alpha of 0.05, we reject HO. There's insufficient evidence to suggest there is no difference in mean backpack weight between sophomores and seniors.
For our last test, we did juniors versus seniors. For our null hypothesis, we did mu juniors is equal to the mu seniors, and alternative was mu juniors is greater than mu seniors. We had a t-statistic of 3.27 and a p-value of 9.00 times 10 to the negative 4. Since our p-value is less than alpha of 0.05, there is insufficient evidence to suggest that there is no difference in mean backpack weight between juniors and seniors, as we have rejected HO.
In conclusion, we found that there was no significant difference between freshmen and sophomores in their true mean backpack weights. However, freshmen had a greater mean backpack weights than juniors. Freshmen had a greater mean backpack weights than seniors. Sophomores had a greater true mean backpack weights than juniors mean. Sophomores had a greater mean backpack weight than seniors. And juniors had a greater backpack mean weight than seniors.
Our hypothesis was correct for all grade levels except freshmen versus sophomores, because there was actually no difference, which shows that this is not where the difference lays. For all of the other grades, the true mean backpack weights for each grade level was heavier than the one preceding it.
Possible errors. A type 1 error could be that we concluded that there was a difference in mean backpack weights between grades when in fact there was no difference. A type 2 error could be if we concluded that there was no difference in mean backpack weights between grades when there was a difference.
We had limitations in our study. There was a confounding variable, which is that it is the end of the year and APs are all done, so backpacks may weigh less than usual for the students in those classes. In addition, honor students may have heavier backpacks than Regent students because they often have a heavier workload, which includes heavier books and a greater number of textbooks.
Ways we could improve this experiment was that if we collected the data in the middle of the year rather than collecting it in the end of the year, since in the end of the year students tend to have lighter loads of books. We could also have increased our sample size, and we could have conducted a true SRS rather than randomly choosing our subjects.
Thank you for watching.
Bye.
Bye.